All right. Let's see here. First of all, a little bit about me. I was at Microsoft for 10 years prior to Zillow, and I've been at Zillow for almost 7 years. And prior to that, I worked for the Coast Guard doing some database programming for them way back in the day. And I was also a Novell network administrator back then before Novell got dumped in 1994 or so. And my whole time at Microsoft, I was a test manager and kind of a group test manager. And then at Zillow, I've been director of test and build and developer tools and release management process. I call myself a director or director of test. If you haven't seen Zillow, this is Zillow here. I just want to point out really quickly the functionality that we have. So you can see there's you can do search from an index. We have a mortgage market. We have advice, professional area, blogging. We have automatic website creation for real estate agents. And we can see, homes and that, whatnot across the United States. And we have a value on every house in the United States for the most part. So just kind of give you some of the idea of the functionality. It's a heavy data-driven site. And we like to call it the database of all homes. Let's see if this works here. All right, so we're going to talk about some of our scaling for velocity. We started off in 2004. I joined in 2005. We had a small dev team and myself as the only tester, essentially. I came in there and I said, well, do you guys have any test process? What kind of tools do you have? And they said, we pretty much have nothing, except for we got some code here in this SVN repository, and we have Track. So I don't know if you guys have ever seen Track. It's kind of a wiki, open source wiki ticket system. How many people here are using SVN actually? Quite a few, okay. So, and we just, we used it in a very simple way. We worked in the code, and then we forked on the release and left that branch kind of behind as a legacy branch, and we continued to always work in the trunk of SVN, which a lot of people do, because merging back is a difficult thing in that particular product. So here I just said, to do builds, we're using Ant, and our release cycles were over 5 months long, and we were doing waterfall development. It's a little diagram just kind of showing how we branched off. The nice thing about this method, it really got us out the door. We were all working together on the single project, on the same, all of the code parts we were working on, kind of like individuals had their own parts to build, so we weren't stepping on each other or anything like that. But after a few of these iterations, the code base started growing really fast, and it got quite large. And we started to find out pretty quickly that we were stepping on each other's toes and kind of getting in each other's way to release different parts of the site. You might get something done, in a month that you want to get out the door, but you got to wait 3 more months for everyone else to be done so you can get the whole thing out the door, right? So good for getting out, but doesn't scale very well. And we had, I think at the time we had about, it was like 10 or so developers, and I hired a contract test team to do the testing initially to get us out the door with about 6 testers. I guess this is an older deck, actually. Yeah, I actually put that in there as a joke. So then in 2006-07 time frame, we started going to feature branches and using kind of a centralized main. We got off of SVN and went to Perforce. We were using cruise control at that point. We introduced cruise control to do continuous builds. which is a really smart thing to do. I mean, you really need the continuous integration, continuous build systems right off the bat. We didn't quite have it, for that first 8 months or so, but we got it pretty soon after we released the product in February 2006. And there's a picture there, kind of the first version of the product, which is kind of interesting because you look at the one we have now. It's very simple looking, but tons of functionality under the covers. This is very complicated looking, but only had one feature, which was to find houses. And we introduced Jira in Fisheye, and we also had Confluence sometime around then too. And we got our release cycles down to a month. The nice thing here was that teams could work independently on their projects and didn't really step on each other. We had a little bit of faster release cycles, so we weren't delivering quite as much code. Those initial releases we had some of them took all night long. We were up until 4 or 5 in the morning on some of those releases, trying to get all the services that deployed to all the machines and everything. So things started to speed up, go fast, and we were able to go home at midnight or 10 or something instead of 4 in the morning. And also the amount of bugs we introduced kind of went down a little bit too, because we're not delivering as much code, which is kind of the whole idea of where we're trying to get to eventually with rapid development and agile development and continuous delivery, if you could do that. We're not there, but one thing though is it increased our test costs. Now we got a bunch of branches and they all need to be tested, and they all need to have the same test plus new tests. And so at this point, we went from using kind of a WinRunner use case tool to writing test cases in Python, and we put the Python test cases in with the actual code in the branch, so they follow the branch and follow the functionality of those branches and get merged together. And we found that Python was a great test tool for us, really fast to write and maintain. Here's a picture of a branch at the time. We got the main, and we had several release and then hotfix branches. So we went from something that was very simple to something that was kind of overly complicated. I think we went too far here. This is the other half of the same thing, actually. That's the top half. Here's the bottom half showing the features. Then from 2.8 to 2.10, we started to migrate. Well, before I go on, part of the complexity here too is these feature branches are, these feature branches are copies of each other pretty much. And in fact, they were full copies at the time, right? And so and it was really a monolithic code base that was just copied over and over. So we kind of, to get more flexibility, we realized we have to componentize and refactor the code. So that was kind of our next thing that we started on. So in 2000 and 2010, and even to this day, we're still refactoring out of that original monolithic code base. So it's kind of an interesting lesson. It was good to get us out the door. We probably should have started almost immediately with a refactoring instead of continuing to kind of build some features that we did at the time. Because the code base got so big, it's become very difficult, essentially, to refactor it. So here we're using, we introduced Maven to help us with the management of our components and modules. And we brought in Sonatype Nexus, and we also brought in Hudson. And Hudson is a continuous build integration type system. It's a great tool. It's got a lot of flexibility to it. And we went to a 2-week release cycle. So within just a couple of years, we went from 5 to 6 month cycles down to 2-week cycles. And here is a picture of our current branching scheme in the main feature branch, the main monolithic branch. And an example of the 2-week schedule. So we would get like a search team and a community team picking up from main and then integrating back into main, and then we would take that code out and put it into the release A or B and do some final testing on it, and then we release to the web. And we do this over and over again every 2 weeks, and we've been doing it since 2008 and so. And once people integrate the main, other branches that aren't shipping in that release, if they can pick up the code, as well as these guys can pick up the code too, and they can start working on the next release. And we have about 10 of these teams right now, so 10 feature teams. And they don't all ship every single time, but we're shipping 6 of them on the 6th. And so it kind of gets piled up. So we're doing two big integrations a day, two feature branches in this next cycle that we have. And this is a picture out of Perforce that just kind of shows a file that was changed and how it was integrated around. You can kind of see that at the bottom is the release branch, and that second one from the bottom is the main. And then you got the mobile branch, so mobile came down into main, then it went into release, and then from release it went back out to everybody else. So pretty straightforward. Part of the problem here is we're merging together, integrating together a lot of the same code again over and over again. And Perforce is really good for doing that task. It's pretty good for doing that task, but the overhead is pretty painful, and we're at a point now where we can't, if all we did was this, and we were just trying to do this monolithic code base with these feature branches, we would not be able to scale beyond kind of where we're at now because the cost of integration is so high. Doing 2 integrations a day takes the whole day. So it's not really a very good model. So compared to the previous model, you know, this was some lower cost for us. I guess I didn't really show the modules, but the modules are essentially branched off of, you can just kind of think of them as another section or another part of this diagram. I think I maybe have a picture later on. And they're Maven modules with POM files in them. And so we just version those as we go along. And those kind of have their own branching methodologies. Talked a little bit about the test difficulty earlier with multiple branches, multiplex test. So we realized at that time that we have to invest heavily in automation. So within a relatively short period of time, we got up to 1,600 test points so that we could test everything within 4 to 6 hours or so, all of our functionality. And we continue to kind of make that a goal. So we have a 1-day turnaround on a full test pass and like a 15-minute turnaround on what we call like a BVT or something. So if we're going to deliver a hot fix, we're able to test a hot fix in about 15 minutes plus a couple of manual checks on the code, and then it's out the door. All right, and so here I talk a little bit about the component release branch strategies where people kind of do what they're doing what they want. They have some flexibility here, so they can branch in advance. And these are unique small bytes of code, right? And so they can do that in advance, or some of them are doing it on demand. So if they have to do a hot fix, then they'll make a branch. And then I start to mention Git here, that we support 2 branches, main and release, but we let developers have as many branches as they want. So 2010 to 2012, we've really been focused on continuing with the componentization, but really trying to get on board with a more agile process and getting out of Perforce and into using Git across the entire company. Here I show we're using Perforce and Git. Our tool list seems to be building. Some of these are kind of becoming, like Ant is barely used at this point. There's a couple things we use it for. Maven, cruise control is, I think cruise control is completely out of the picture now, but it's almost out. Hudson and Jenkins, so those are the same thing. So we're in the middle of migrating from Hudson to Jenkins. And then Nexus, Sonar, and Coberta, which is a code coverage tool. Then we got Jira and Greenhopper and Fisheye and Crucible, and Garrett, which was the Git repository code review tool that we were using initially, and now we're moving all that to Stash, and we're actually almost done with that. And we're maintaining a 2-week release cycle right now. So the teams are going agile with Greenhopper. We're not trying to drive agile as like a specific process with Scrum Masters and stuff. We're letting teams kind of do things the way they want to do them, as long as they can deliver the code on schedule, and they feel pretty good about it. Then that's pretty much okay with the release management and the business side. However, most of them are doing stand-up meetings with cards and things on the wall. Some of them are using the Greenhopper on a computer and moving the tickets on the computer for the backlog. What we're doing, and an important thing we realized 2 years ago, was that to truly scale out, we need full developer participation in the building of the product, right? So a big part of the work that we were doing in Hudson and Jenkins is to enable the developers to create their own build jobs, essentially, and well, yeah, exactly, that's what that is, just create their own build jobs. That's as far as we've gotten with it. We don't have a way for them to create an environment to deploy into, which is something we're going to have to do in the future to continue scaling. I only have a couple of guys on our build team, and they're servicing right now. We have 65 developers in these 10 feature teams, and we have about 14 or so test environments. It's pretty hard for those guys to get it done by themselves, right? So all the configuration, for instance, is owned by development. It's reviewed by build, but it's owned by development. We're still having some learning curve with getting people out of Perforce, going into Git. There's one of our developers says, "No way, I'm not moving." I don't know why. He just doesn't want to. And again, here's a test automation, which is currently now about at that 3,500 test points level. And we've also introduced in the last couple of years in our test cases Selenium inside of the Python framework, because we're getting more Ajaxy on our website. Before we were Ajaxy, we were able to get away with just doing gets and regexes against the content. It was a lot easier, actually. We've, as part of scaling for the velocity here too, we're enabling the developers to leverage our test infrastructure, test data, and test kit through a web service. Essentially, we're exposing our Python managers into a web service, so they can actually, in their tests, whatever language it is, right, they can request those objects and then go ahead and test against them. And that's going to help out a lot too, to get them more involved in that. So we're not great right now at doing unit integration test levels. We do have code coverage. We just started for that, and we're going to set some goals around the company, some soft goals to start off with, but probably something like 40% coverage, just to make sure that we got some tests in there. So I think a big part of our velocity decision, in addition to having these tools automated and getting developers involved in the build and deployment process, is going over to Git. We kind of experimented with it for a while, found out a few things that we really thought we need to do. It's best practices, I kind of mentioned them here a little bit with a kind of a common template and making sure people auto rebase before they push back to the remote repositories, and implementing hooks in Jira, and also making sure that those hooks work in an offline mode as far as kind of like checking for preconditions, but Jira isn't there, right? We've also decided to allow all of our senior technical staff full access to Stash to go and create their own projects and repositories. And again, that helps us, the two build guys, not get, so they don't get overwhelmed. The hooks are really interesting. I mean, how many people here use any kind of hooks in their source code check-ins to make sure people have ticket numbers and stuff at least? So a couple. It's really irritating from a test point of view, especially when you're trying to discover what the risk is in your product if you can't associate the code with a ticket. So that's one of our basic rules, but we have more rules in addition to that. When we're in critical phases, we can enforce any number of fields out of Jira against a template that we have to block check-ins, essentially, to make sure that those values are correct. We introduced a field that was kind of a branch name because developers would get confused as to which branch to check in. So we would put it in the ticket, and if they tried to check in code that didn't match the branch name in the ticket, then they would get rejected. And they come complain to us, well, this doesn't work. And I said, well, where are you trying to check it in? Oh, it's the wrong place. That's the other branch. We're not using that one, or whatever. So sounds like we're going to get some hook support put into Stash, which is going to be which would be nice. It's a natural integration, really, between these check-ins, check-in comments, and the Jira workflows that you have. So I think it's a really important part of the tool set. I mentioned these are just our common config. We use HTTPS, so you have to kind of put your certificates and stuff in your system. And then we got these rebasing features and whatnot here. We also, on the server side, we're denying deletes right now, which means you can't delete a branch, and deny non-fast forwards, which is a way to kind of screw your code up. It's not a good thing. So more about the hooks. I guess I mentioned here a little bit how the tool sets in and of themselves don't really have any management for these. You have to write your own code. So our new Git hooks, the code that we're writing right now is a Python library that we actually will push to people's machines, and that will populate the functionality of the hooks directly into the .git/hooks directory. It gives us a way to kind of like manage that from a central location. Part of the problem with the distributed source control here is that these things are all over the place, so you don't have direct control necessarily. So this gives us a little bit of direct control. And I gave an example here of that's a shortened version of the query we use. We actually querying in the current one with the Perforce version of this. We query the Jira database directly, and then I have the command line here and a sample of the XML, and the XML defines the rules that we apply. The query gets everything we need out of the database. With the Git version and the Python code that we wrote, we're using the API instead, the REST API against Jira, which is the right way to do it. Yeah, it's kind of talking a little bit about some of the tools that we have, some issues we have with those tools, this linking problem for management in the tool set for, you should be able to automatically kind of create these, add a repo to Stash, it should show up in Fisheye, and the link should go back to Jira automatically so that you could do smart commits. So it's something I'm asking the tools guys to get done, and it seems like they're heading in that direction. And then I think the main there's two messages, right? So code will grow in complexity, and so refactor often and early is a great practice to have. And people talk about it and they don't do it, right? So it's a lot better if you could enforce that or just get it done. Put it right into your schedule, like every other project. Do some refactoring. We're actually starting to do that now to make sure we can finish up the rest of it. And then try to make the tools as fast as possible. So people are waiting to use stuff. They're waiting for, like I mentioned, like in this last slide, if 60 developers waited 5 minutes a day for a slow tool to respond, that could end up costing you $50,000 a year in wasted time, because just those moments of waiting add up quite a bit, actually. You got to fill out a ticket, you go down, 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 it takes a lot of time. So the new Jira 5.1 looks great. That's going to help out a lot in speeding up that process. There's also I don't know if you saw the Python, Jira Python tool that was made by Ben, his fellow Ben, I think is his name. You can, I'm actually going to get that out to the developers because they can create their own tickets right from a little shell script, essentially, in a faster way than in an easier way, I think, than the command line client does. So here I'm mentioning like what we're managing today. We're managing 41 or so repositories. We're getting about 4,000 commits a day, and we're managing 225 million lines of mostly duplicated code. And we have 800 or so libraries that are now going into Nexus that we assemble for deployment. All right, well, I guess if open it up for questions. I think if anyone has any questions, it'd be great.
So you said that you are moving from Garrett to Stash. Can you talk about what Stash gives you that Garrett doesn't?
Okay, yeah, the question is, talk a little bit about the move from Garrett to Stash. Has anybody here who's familiar with Garrett at all? Like, you are? Okay. It's a repository management tool for Git. It offers it's SSH only, and it has some security model built into it, and you can enforce a code review for every check-in. Stash has kind of a different model. We're using it over HTTP, and we're using our Active Directory now instead of a Linux LDAP derivative that we have. So it's kind of nice because now we're using the same accounts that people use to log on the rest of our domain. They're bringing in SSH support because some developers just prefer that. And they simplified the security of it, essentially, right? So how you manage the users against it. There's really just a couple of roles. It's very simple to put that together. It's also great at kind of visualizing the code. Garrett doesn't visualize it very well for you at all. Stash is just got some amazing diff views and views of your branches, and it like jumps you right back over to Jira in a nice way.
I haven't really looked at Stash visually. Is it better than Fisheye's view, you think, or? I haven't really looked at at Stash visually. Do you think it's better than Fisheye's views?
Oh, yeah. Yeah. So Stash, they built it from scratch. Fisheye, Crucible were kind of hacked together, and they've done the best they could. I think they get those. They have to do some big refactoring there. But Stash is from scratch, and it's fast, and it's Ajaxy. It looks cool. So all the developers, when I passed it out to people, they're just like, "Ooh, this is awesome!" Right? I've never kind of like had such a good visceral response from my developers before. For rolling out a tool. Usually people get frustrated with tools.
Cool. Thanks very much.
Sure. Yeah, sure. Any more questions?
Cool.
No? All right.
Right on. Thank you very much.